Find the derivative of the following functions using the definition of derivative. So we're just copying out the definition of derivative, which is right here. So if you don't want to rewrite it, you don't have to. F of x equals 4x plus 5. The only difference between this example and the previous example is that for this one, x is just x. X is not a number anymore. The bad fall for the previous example is, for instance, if we wanted to find the slope at 3 and then find the slope at 4, we'd have to do the entire thing over again because the number changed from 3 to 4. Whereas if you keep it as an x, it's a lot easier to find many different slopes. So in the long run, this formula is more beneficial than the one with the a's in it. Okay. Notice this is a polynomial. It's a linear function. So this will cancel out very nicely. But we'll get to some that aren't so nice. So the setup would be the limit as h approaches 0 of, well, you know what, I'll just copy the formula down. F of x plus h minus f of x all over h. So the first term there, instead of the x, you're going to plug in, no, other way around. Instead of this x here, you'll plug in x plus h. So we'll have 4 times the quantity x plus h plus 5. So this part was the f of x plus h. Minus f of x. What is f of x? Since 4x plus 5 is more than one term, what do I need to put around it? Parentheses. So unlike the previous one where there are numbers, we can't just evaluate this. We actually have to keep it as the expression 4x plus 5. All over h. Now what do? Yeah, we'll distribute the 4 and the negative 1. Is that okay? So we'll have 4x plus 4h plus 5 minus 4x minus 5 all over h. What cancels?
4x minus 4x and 5 and 5 is 12.
Very good. What are you left with in the numerator? So we'll have the limit as h approaches 0 of 4h over h. What is 4h over h? 4. What's the limit as h approaches 0 of 4? We're sorry?
0.
4 is a constant.
Oh, so then equal.
Very good. Alright, so now let's do the ultimate kick you while you're down. This was a complete waste of time. Why? What's the slope of the line? 4. Well, if you think about it, any line, if you pick any point on it, the tangent line is the exact same line. So it should have the same derivative, that being 4. So this, sadly, was a complete waste of time because we could have just said 4. However, the next one's not going to be lines. In fact, I wouldn't expect many lines on your test. Maybe on your worksheet and project, we'll see, but not on your test. Because this is way too nice. We can't have you guys think that this is nice. It's too much. Part by g of x is x squared minus 9x. Same stuff. So instead of f, we have g. Doesn't make a difference. If you would, please set up the difference quotient. What is g of x plus h? You don't have to expand it just yet, just plug it in. So g of x is x squared minus 9x. How would we find g of x plus h? Oh, in stereo. Uh-huh. There's like a tag team going on there. Since x squared minus 9x is more than one term, we need parentheses around the x squared minus 9x. Is that okay? All over class H. So notice the first one was linear, not too much in the distribution category, meaning the step after this one. However, once you get up to higher powers or different types of functions, then the next step after this gets a little more exciting. So here we'll have to square out the x plus h, distribute the negative 9, distribute the negative 1. Okay? But again, since it's a polynomial, things should cancel. So if you would, please give yourself a minute or two to square everything out. Try to finish this one on your own. You will have x's in your answer. It won't be a number anymore. What cancels? Yep. So upstairs we're left with 2xh. What else? Plus h squared minus 9h. Running out of room. So, if we were to factor out an h from the numerator, we would be left with 2x plus h minus 9 all over h. The h on the outside and the h in the denominator cancel. You're left with 2x plus h minus 9 as h goes to 0. Okay. H is really your variable here. So if the term doesn't have an h, then it's considered constant. So 2x does not have an h. So as h goes to 0, 2x doesn't go anywhere, it just goes to 2x. So this is shooting off to 2x. This h, however, is going to 0, and negative 9 is going towards negative 9, yeah. So what's our answer? 2x minus 9. So we just found g prime of x is 2x minus 9. Is that okay? Okay. We're going to use that result for part C. Part C. Find g prime of 2. Well, previously we found g prime of x was 2x minus 9. In other words, we made a whole new function, just happened to be called g prime. So when we want to find g prime of 2, what do we do with that 2? Plug it in. Is that okay? So we'll say g prime of 2 is 2 times 2 minus 9 is negative 5. So that says in English, the slope of the tangent line at x equals 2 is negative 5. The reason I'm saying it that way is part D. Find the equation of the tangent line at x equals 2. So for us, we need a point and a slope. We already found the slope to be -5. So we know x is 2, and we know our function g of x, what was it, x squared minus 9x? Correct. So we need to find the y-coordinate. Anytime you want to find the y-coordinate, you go back to the original function. So we found g of 2. What is 2 squared minus 9 times 2? -14. So one more time, we have to have a point and a slope. The point comes from the original function. What's our point for our example? 2 -14. And our slope was -5. Coincidentally, when I play the lottery, these are the numbers I pick. Yeah, that was the result I was going for. We got ourselves a point. We got ourselves a slope. You can use point slope. You can use y equals mx plus b. Your choice, doesn't matter. So to check, you can graph the original function x squared minus 9x. You could also graph the line y equals -5x minus 14. They should be tangent and the point 2 comma -4, excuse me, -5x minus 4. They should touch at the point 2 -14. I think we have one more part, and that's the end of this example. And actually, this will be the last one we do today. Sad sound. Good response.